Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 7.1, which is an intro to trigonometry. Typically in a traditional track, you learn a little bit of trigonometry as you get into your junior year, and then if you are going on to a fourth year of math, you'd be covering trigonometry in a little more detail and going into calculus. Because we're on the integrated track, you get a little bit of trigonometry in Math 2, a little bit in Math 3. So Unit 7 will sort of introduce you to some of the trigonometric topics that we'll be covering, and then we'll move on to other things for the second semester. But Unit 7, like I said, is going to be focusing on that intro to trigonometry. So we'll go ahead and just jump right into it. For 7.1, we are looking at an intro to trigonometry. Specifically, we're going to be looking at the first three trigonometric ratios. So there are a few things that we can do with trigonometry, but the first thing that we really focus on is looking at right triangles. And what we notice is that there are certain relationships that exist in right triangles, and certain patterns exist that we identified. So looking at a right triangle, there are ratios that exist between the given sides. Now, ratio, of course, is another word for a fraction. So when I'm looking at a right triangle, and we'll just construct one here real quick. Obviously, a triangle has three sides. And because there are three sides, if I'm looking at a ratio of those sides, I could have technically a total of 6 ratios. Because there are 3 choices, a ratio is a numerator and a denominator, so technically there are a total of 6. However, for our purposes, we're only going to focus on the main 3 ratios for right now. Those 3 ratios are sine, cosine, and tangent. For a given angle in a right triangle, and it could be this bottom angle here, it could be this top angle here, but for, let's say, this angle, there are 3 sides. There is, of course, the hypotenuse. Remember, the hypotenuse is always going to be the longest side of a right triangle. It's also going to be the side that's opposite your right angle. So the hypotenuse will never change in a right triangle. For the other 2 sides, those are legs. But because we're referring to those 2 legs from a given angle, in this case the bottom left, there is a side that is opposite that angle, and there is a side that is adjacent or touching that angle. Now, of course, an angle is made up of 2 sides, but one is the hypotenuse, which we've already identified. So the other side that's touching that angle is the adjacent side. Now, as I mentioned, the hypotenuse will never change. The hypotenuse is always going to be the same side. It's always going to be the side opposite the right angle. It's always going to be the longest side. But depending on what angle I'm looking at, if I'm looking at the bottom angle in this triangle, then this side is opposite and this side is adjacent. If I was looking at the top angle, then the opposite and adjacent sides would switch places. So just pay attention to which angle you're looking at. Sometimes these will be labeled with vertices. It could be triangle ABC. Sometimes it won't be, depending on the problem or the context. Okay. So, using this information for 7.1, all we want to be able to do is write a ratio of the given sides. Those 3 ratios that we're going to be focusing on, again, are sine, cosine, and tangent. If you're using either Desmos or if you're using a scientific calculator, a TI or Casio, you'll see these functions abbreviated on your calculator as SIN, COS, and TAN. So those are the abbreviations. If you're using it as a function on your calculator, that's the button that you would press. Okay? Again, these are all ratios. Ratio is another word for a fraction. Sine is defined as being the opposite side over the hypotenuse. Cosine is defined as the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. So if I asked you to find the sine of a given angle, all you're really doing is finding the two given sides and writing it as a fraction. To remember this, there is an anagram that's used commonly to remember the ratios for sine, cosine, and tangent, and that is SOHCAHTOA. So S-O-H, sa, C-A-H, ka, T-O-A, toa. So SOHCAHTOA. And that tells you the ratios that you need. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. That helps students. If that helps you, use it. If not, then just as long as you're able to generate those, because on a test you won't be given the ratios. So you need to know what the ratios are. On your assignment, what this looks like is simply you're going to be given a triangle. And rather than having opposite and adjacent and hypotenuse written here, you're instead going to have actual values. So, for instance, let's say I have 3, 4, and 5 written here for this example. So I could ask you, well, what's the sine of angle A? And so to write the sine of that angle, you are looking at the measurement and you're going to write the ratio. Looking up here, sine is opposite over hypotenuse. So for angle A, the opposite side is 4. The hypotenuse is 5. So your answer is simply 4 over 5. You're just writing the ratio. If I asked you for the cosine of that angle, you're looking at adjacent over hypotenuse. So for this angle, 3 is adjacent, 5 is the hypotenuse. So that is 3 over 5. And if I ask you for tangent of that angle, that is opposite over adjacent. Opposite side is 4, adjacent side is 3. So that is 4 over 3. Now typically if you're asked to do these types of problems, the question is going to indicate which angle you are referring to so that you know which side's opposite, which side's adjacent. Here, we labeled angle A, and specifically in the question, it asks what's the sine, cosine, tangent of angle A. As I mentioned, this can change based on what angle you're asked to refer to. So hypotenuse will always be the same, right? Because it's always opposite the right angle. But let's say instead of angle A, I asked you to find the ratios for angle B. So if I'm asking you to look at angle B, see if I can get that without doing there. So if I ask you for the ratios for angle B, then AC would be the opposite side, and BC would be the adjacent side. So hypotenuse will stay the same, but opposite and adjacent will change based on which angle you're looking at. So for angle B, if I ask you to find the ratios, sine of angle B now, same ratio, opposite over hypotenuse, but because opposite and adjacent have switched places now, 3 would be opposite and 5 would be the hypotenuse, so this would be 3 over 5. If I asked you for cosine of B, the adjacent side is 4, the hypotenuse is 5, so this would be 4 over 5. And for tangent, that is opposite over adjacent. So for angle B, opposite is 3, adjacent is 4. So your ratio is 3 over 4. So that's all you have to do is fill out the ratio. Looking at these numbers, we should notice some patterns, right? The sine of one angle is the same as the cosine of another, and vice versa. And then if I look at the tangents, they are reciprocals of each other. But all you really have to do for this assignment to do well is just be able to recognize what your sides are, opposite, adjacent, and hypotenuse, and then write the ratios. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.